Hello, my name is Kendall Hayes and I'm here to give a short presentation on the uses and applications of thermosets as coating materials. I'm a senior currently at Pittsburgh State University studying plastics technology and engineering. So let's get started here. To start off with, you're going to know the variables you're going to need as with any application you're going to do. You're going to know what physical properties you're going to need and what chemical properties you're going to need, both in the surface you're applying to and your resin you are putting onto said surface. Some examples of physical properties you're going to need to know would be surface tension, modulus, and coefficients of thermal expansion, things of that nature. Your chemical properties, you're going to need to know that your structure, your conformation, things like that, just so you're going to know how the functional groups are going to interact. Now, to start off with, we're going to compare the differences between your thermoset and your thermoplastic coatings. Thermoplastic coatings are recyclable, which is a key factor in all thermoplastic materials. They provide electrical insulation and high corrosion resistance. But unfortunately, these thermoplastics, they can soften when reheated, and they're more expensive, which is a very big part of it. Thermosets are traditionally going to be what you're going to use more, which mainly because they're cheaper. You're always going to want to use the cheaper one if you can. And they provide excellent dimensional stability and heat resistance as well. Unfortunately, thermosets, like I said earlier, the thermoplastics can be recycled, thermosets cannot. And some surfaces, they can be difficult to finish on. So next we're going to go into powder coating. There's going to be a video that plays immediately whenever I hit this, so get ready. That explains basically what powder coating is.
This is how powder coating works. The actual powder is made out of polyester and pigments and is placed inside the gun's hopper. Once the air line from the compressor is attached, by pressing the trigger, the compressed air propels the powder through the barrel of the gun. Here the paint is positively charged by an electromagnetic coil up to 50,000 volts. At the same time, the part to be coated is grounded through a wire and negatively charged. Consequently, it attracts the polarized powder, retaining it and somewhat self-leveling it. Once coated, the part can be put inside an oven. At 200 degrees Celsius, 400 Fahrenheit, the powder liquefies, and within 10 to 20 minutes, the curing process turns the molecular structure of the powder into a very resistant yet elastic plastic coating.
So after seeing that, it shows you basically what powder coating is and how it works. I'm going to also add it can serve a variety of metal applications. And whenever you do this, it provides very high corrosion, temperature, and impact resistance. These powder coatings also have a wide variety of colors, glosses, and textures. You can see in the top right corner, that's a very abstract demonstration of just the stream of it coming out and the different colors you can have and how the powder how it actually looks compared to your traditional paint. Now, to start off, we're going to get into our resins of choice. The first one being epoxy, which they're a very big part of coatings. 53% of all your epoxy applications are actually coatings. The epoxies have very strong chemical resistance, and they also provide high toughness and durability, which is very key for the epoxy coatings. The epoxies also are very strong adhesives, but unfortunately epoxy-based coatings can turn yellow whenever they're in outdoor applications, which makes them unideal in certain situations. Next off, we got our polyurethanes, which are strong adhesives as well, but polyurethanes are definitely more flexible than your epoxies. Polyurethanes have high electrical and high chemical resistance, but they have pretty good weatherability as opposed to your epoxies. Unfortunately, the polyurethanes can be a bit expensive, especially compared to very similar applications of different types of resins as well. Next, you got your polyesters, which these are specifically your carboxyl polyesters as opposed to your hydroxyl polyesters, which are your polyurethanes. Now, like I said, they're very similar to your in functional groups, so they have very similar mechanical properties, but unfortunately, as you see in this graph, polyester is a bit lower across the board in your hardness, chemical resistance, flexibility, matting ability, and film thickness. Even so, your polyurethane, you're going to be paying a premium though to have those better properties as opposed to your polyesters. One thing to note with the polyesters is they are definitely more moisture and temperature dependent than other resins. So, finishing this up, I'd like to just thank you for watching, and my name again was Kendall Hayes, and have a good day.